Welcome to question 8. As you can see, we're required to solve cyclic stated above. You can see that we have point A up to B, which part is B, and then you have the lines that AB and CF that are parallel. Then let us go and highlight the problem. Okay, so those are the questions. Question 8, as you can see in the diagram, you can pause and read. So the requirement to solve the problem is stated down below, prerequisites. So the prerequisites there, you can just pause there and then know all the information. So this is the information that we have as you read on from the problem. Remember to pause because I'm just trying to make it fast so that it doesn't consume much of your data. So prerequisites there, you can say know how to differentiate diameter, and then you have angle A is equals to 90 degrees. So the reason there would be that that is BE is equals to is the diameter. So when B is the diameter, how do we know that? Because the center, then that means that the angle subtended by a diameter will be equivalent to 90 degrees. And then that is the angle that a diameter subtends, and that is, you know, the differentiated diameter under code. So we have 8.1.2. Let's see what they want. They want us to solve angle E1. So angle E1 there will be equivalent to 80 degrees. So let us go find out our reason. Our reason in there, E1 there will be opposite angles of the cyclic quad, so that we see that is 180 degrees. That will be E1 is equals to there is 180 degrees, and the reason is that supplementary angles add up to 180. So the other side is 100, that will be 80 degrees. And then we come in and find out that is giving in the reason that BCDE is cyclic quad. So that's part of the reason. Okay, and then those are theorems. So we only use theorems and facts about cycles. So we're going to 8.1.3. So 8.1.3, as you can see, they want us to find angle D. So angle D there, let's construct angle D1. So you find that you have E there. So remove part of the shape that we want and solve for it. So we have angle E there, there's D. So if it's moving too fast, remember to pause and follow along. So you don't have to just watch, you need to sketch it as well. Then from there, equivalence, we can see that 80 degrees, that's 80 there, and that's E1, that's 80 degrees. I'm just gonna fit the 80 there, it's a small space. Okay, so that's E1 80 degrees, and then that one is 100. E2 is 100 degrees. Okay, so you find that E2 is a straight line. So since it's a straight line there, then that means that the other part will be 100 degrees. So 100 degrees. So now you see that we have angle D1 there as 180 minus 100 plus 35. So it's like 180 minus 100 degrees plus 35 degrees. So it's 180 minus 135. So you can find the difference there to be probably 45. So I think that will be 45. So I'll just take some time to calculate, but hopefully you can see that we have 35 there, 45 as our possible answer. That is through calculation. So I just pause, make your own calculation, then as we come back, as you can see that now we have the accurate answer, which is 45 degrees. So 45 degrees will be our equivalent of angle in D1. So the reason there would be sum of angles interior triangle. Okay, so that is interior of triangle. And then we are required to prove that AB is perpendicular to to CF. So once again, we go through and find that, okay, so we have there, we have A, we have B, so that's the AB there, and then we have F and we have C. You can check on the that they're parallel. So once again, we draw a line there that means B and F, and then we check for alternating angles. So those are the properties of parallel lines. So the angles are the same or not. So let us prove it. So as we get to solve for angle B, in this case we'll see which part of the B we need to solve. The part of the B that is part of the that touches the parallel line. So it's going to be 90 degrees. So 90 degrees there, that is part of the ABE triangle, plus 50 that 50 degrees, yeah, that's 50 degrees. It's not 50, it's 55. If I'm not mistaken, it's 55 degrees. So that's 55. So 55 degrees. And then once again, we find the equivalence 180 minus 90 plus 55. That gives us 35 degrees. So once again, we see that the angle there is equals to the angle F. So that is angle F there. So angle F, properties of parallel lines, so the alternating angles are equal. So alternating angles are equal, and then that means that alternating angles equal. So you can see, remember to pause the video to have a clear view of what is happening. So angle AB is parallel to CF, for reason alternating angles. So that is how I would put it in that case. So yeah, that's it. So you can go in and check all your angles, and then yeah, if it's moving too fast, remember to pause. And then this is your homework. You're required to find BC there, 2 marks, and if A is CD is A, and those are the information there. If the radius of that, yeah. So you can pause in and then write in the information so that you can answer. Don't forget to subscribe. Good luck on your homework. Thank you.